We will now find two positive numbers whose product is 36 and whose sum is minimum. So this is one of the optimization problems that we are going to work it out to determine the two positive numbers. Here I have outlined the strategy or the steps that we can utilize to work out the optimization problems. And so we will follow these steps to determine the two positive numbers. The first step, we have to draw a picture. Actually, we have to find only two positive numbers, so we will not have to draw a picture for this problem. So we can ignore this step one. Now let's move on to the step two. In step two, we have to identify the quantity that is to be maximized or minimized, and we have to determine a formula for that. This is basically the objective function. So considering this problem, we are clearly given that we have to determine that the sum is minimum. So we have identified that the objective function is basically going to be the sum function. So let's write down the sum function. That is sum should be minimum. This is our objective function. So let's write down this as a function notation. So first, I'm going to consider the two positive numbers that we are going to find as x and y. So let these two be the variables that represent the two numbers. We are given that the product is 36. So we can say that the product of these two numbers, that is xy equals 36. And the sum has to be minimum. The sum of these two numbers, which is x plus y. Now we know that this is one of the constraint that we can utilize. That is, the product has to be 36 and the sum has to be minimum. We identified that the sum function is the objective function. Now, as according to the step 2, we have to find a formula for it. So we have determined the formula for the objective function. And now let's move on to the step 3. That is, in step 3, we have to use the given constraint and rewrite this as a function of only one variable. As we see that s equal to x plus y, let me rewrite this. So this is in terms of two variables, that is x and y. We have to convert this and rewrite as a one variable. For this, we will be replacing this constraint equation. This is the constraint equation, that is xy equals 36. So from this, we can solve for y. So I solve for y from this equation, that is xy equals 36. So I divide both sides by x so that I get y. So I get y equals 36 over x. Now using this equation, I'm going to substitute into this objective function. So therefore this becomes s equals x plus y equals 36 over x. And we will write down this in function notation. So I'm going to write down this sum function as s of x. This equals x plus 36 over x. And this means we have completed the third step. Now let's move on to the fourth step. That is, using calculus, we have to maximize or minimize the objective function. As we already told that we have to find the minimum value of the sum. That is, the sum has to be minimum. So basically, we have to we have to minimize this function. Minimize the sum function. And so for this, we are going to use the calculus. That is, the first step in minimizing the objective function is to determining the critical points. So let's determine the critical points. We know that the critical points occur at the first derivative equals 0. That is, the first derivative of the sum function is s prime of x equals 0. So let me find the derivative of this function. That is s prime of x, which is the first derivative of the sum function. This equals the derivative of x is 1 plus 36 over x. This we can consider as 36 times of 1 over x. So when we apply the multiple rule, constant multiple rule, we can keep the 36 as it is and then find only the derivative of 1 over x. So this could be considered as x raised to the power of negative 1. And then we apply the power rule to find the derivative of x raised to the power minus 1. So we put the negative 1 in front and reduce that power by minus 1. So minus 1 equals negative 2. This could be written in positive powers of x, that is negative 36 divided by x squared. So basically the derivative of 36 over x is negative 36 over x squared. So I'm going to replace this as negative 36 over x squared. And to determine the critical points, we have to set up s prime of x equal to 0. So therefore, I'm going to replace this s prime of x equals 0. So therefore, this equation becomes 1 minus of 36 over x squared. Now we have to solve for x from this equation. So first let me add 36 over x squared to both sides. So this means I will get 36 over x squared. This equals 1. And then I cross multiply or I multiply both sides by x squared. So I get x squared equals 36. And to find x, we have to take the square root. So when you take the square root, we get x equals plus or minus 6. But since the numbers are positive, we can ignore the negative quantity. So we just say that x equals 6. So this means we found the value of x equals 6. However, we have to determine whether this gives the sum to be minimum. So for that, we have to take the second derivative of the function. So let's do that. I'm going to copy maybe I could do it here. So I'm going to find the second derivative. So I have s prime of x equals 1 minus of 36 over x squared. Now let me take the second derivative, that is s double prime of x. This equals derivative of 1 is 0 minus of, let me do it separately here, that is we have to find the derivative of 36 over x squared. So this can be considered as 36 times of x raised to the power of negative 2. So basically we just have to find only the derivative of x raised to the power of negative 2. So this means when we apply the power rule, it becomes negative 2 x raised to the power of negative 2, negative 1, which is negative 3. So basically this comes out to be 36 times of negative 2 is negative 72 over x cube. So the derivative of 36 x raised to the power of negative 2 is negative 72 over x cube. So I'm going to replace it over here. So therefore this becomes negative of 72 over x cube. And so this becomes a positive 72 over x cube. So this is our critical point. To determine that the function is giving a maximum or minimum value at this critical point, we have to plug in the critical point into this second derivative. So let's do that, which means we are basically finding s double prime of 6. So this gives 72 over 6 cube. We don't have to exactly calculate the value. All that we need is the sign of this second derivative. Clearly, this is going to be a positive quantity, and this means the sum is minimum at this critical point. We see that the sum is minimum at this critical point of x equal to 6. So clearly, x equal to 6 is the number where the sum is minimum. So we have identified the one of the numbers, that is x equal to 6. So one of the number is x equal to 6. Now to determine the other number, let's go back to our original equation or the constraint equation. So we have the relation y equal 36 over x. We can utilize it to determine the second number, that is y equals 36 over x. And this gives, when we replace x equal to 6 into this equation, we get 36 over 6. This is equal to 6. So therefore the two positive numbers are 6 comma 6.